Okay. All right. Well, welcome. Um, Happy Monday. And what I want to do first is talk about this lockdown browser. And so, can you let me know, has anybody had to install it yet for any of your other classes? Yeah, if you can unmute your mics, then just let me know. I don't know about the texting thing. Let's see, chat.
It seems like a lot of people have.
For most of them? Okay.
Yeah, because they're commenting in the text
Okay,
box
yeah, I
and
see that.
it's a chat message.
Cool. Okay. Yeah, so most of you have it, and so it's running. Yeah, again, if you have technical problems, good. Yeah, if you have technical problems, the help desk should help you iron those out. But good. If you haven't, here is the website. So let me get rid of this thing here. There we go. There's the website. If you just do a Google search for lockdown CMitch, or I guess lockdown browser CMitch, then you'll be taken to this screen, and then it's got instructions on how to install it. You know, either PC, you have to log in, but you can install it PC, Mac, or an iPad as well. And so I guess your next midterm is coming up. You have a few weeks before it anyway, but yeah, the earlier the better if you can test it out just to see if it works for you, and then let me know if you have any issues with it. What I'm allowed to do on the lockdown browsers to set up separate windows, and so I can let you open up certain things. And so one of them, I'm going to have your periodic table with the names and everything, so that will be available. And then you'll be able to use your own scratch paper and a calculator. I also will have a little browser window with a scientific calculator, but you can use your own if you want. But it'll be you'll need a computer with a web browser because it goes through a check for your or a webcam, and so it'll go through a check for your webcam first, make sure it's operational, and then it'll take you to the exam. And so just like for my other class, I've got a midterm tomorrow for them, so I guess that's my test to see if it works or not. But I guess it should work fairly simple. I don't know. I guess we'll see. I guess stay tuned. If it burns horribly, then I guess I'll use that experience to improve yours. But yeah, hopefully everything goes smoothly with that. But your next midterm and the final will be using that. Okay. Okay, so I want, again, I guess, yeah, let me open the chat box, I guess, if you prefer to chat it in. Microphone doesn't work. Okay, yeah, that's fine. Okay, so I want you, I want to, have it, I really miss being in the classroom in front of you guys, to kind of have like an open dialogue. I want to do it as seamless as possible. I want to work out some review, just some naming review. So I covered a lot in the last lecture, and one of the topics was naming all these ionic compounds. And so I wanted to go through a variety of questions, and I want you to take a stab at it. We're going to do the first question together just to remind you, because it's been a few days. But then I want you to work on, questions, the rest here, questions 2 through 7 and the rest, to come up with the names for these, and then we'll discuss them. And so I put this up. So again, this is what I will give you on exams. And so I'll have this, I guess, as another window that will be there. Or maybe I'll just put it on the actual exam, or I'll figure out a way that I'll supply all these names and formulas of these ions for you. And so with these, if you're to come up with the proper formula, so this is going from name to formula, and then we're going to go vice versa here later. The strategy is for the name to formula is to put what the ions are first. And so for this copper 2 sulfate, the copper 2, what does the Roman numeral 2 refer to? That's a lot of 2's in there. But what does the 2 indicate? Anybody remember? Yeah, so the 2 is used for only the transition metals and tin and lead. Okay, the only ones where you have to use Roman numerals. So you'll notice a lot of these others don't use them. And this indicates the charge. Okay, so the strategy will be, so if it's copper 2, then we write, so it's copper 2, and then sulfate, so you're going over here, and then you look, so sulfate is SO4 2 minus. Okay, so the question is, how do I put those ions together, like the ratios of those, so that the charges all cancel? So what do you think the formula should be for this compound then? So they're both a plus, so you have a +2 and a -2, and so those will cancel, right? So they'll both equal, if you add those up, you get 0, in other words. And so all you have to do is just write the ions in this case. And so it's CuSO4, okay, so that is copper 2 sulfate. What would it be for copper 1 sulfate?
Question.
Yes, yes.
So you want your ions to cancel so that it has a 0 essentially?
Yes, correct, correct.
Okay, so it's a neutral. So it's a neutral ion.
Mm-hmm. Yeah, it's a neutral compound. Okay. Yeah, so yeah, the ions have charges, but they have to cancel to give you 0. Yeah.
Okay.
Overall.
Awesome.
Yeah. Okay, and so copper 1 sulfate, the charges are that, right? So now how do you cancel the charges in that one for copper 1 sulfate? So you have negative charges of -2, and so you have to get positive charges of +2 overall so that these cancel. So how can you get 2 of the coppers?
Would you just like multiply the copper by 2?
Yeah, and the way, yeah, so that's right, but the way you write it in the formula is you just write it as a little subscript. So it's just that. Okay, so that indicates that you've got 2 coppers and 1 sulfate. Okay. Does that make sense? Yeah, you can text if it doesn't or whatever too. Okay. All right, so what I want you to do is take a few minutes and work through these others. Let me scroll up here. Guess I can't get the whole thing on here. Maybe if I decrease the size. There we go. There we go. Okay, so questions 2 through 10. I want you to take a stab at these names. And again, these are the ions that you're going to be dealing with. What do you do if it's just oxide? So oxide isn't on this list. But what is this? So oxide. So that just means just the element itself. Okay, so it's just oxygen, and it's a -2 charge. Okay, so remember this, right? So these are the charges of the ions, the preferred charges. Okay, so this would appear as oxide, sulfide, chloride, fluoride, all those charges. Okay. All right, so take a stab. I'm gonna pause the recording just so that we can take a stab at it. And if you have questions, please either text it or shout it out through your webcam mics there, and then we'll go through them. Okay, there we go. I started the recording now again. Great. Yeah, so the charge actually is the same. Yeah, so the sulfite is still a 2- charge like sulfate is. It just has one less oxygen. Yeah. Okay, so that would be sulfite. Aluminum, what charge does aluminum like to have? I can go back. Yeah, +3. Yeah, so everybody got that. Good, good. Yeah, so aluminum 3+. Okay, so with that in mind, what is the formula for aluminum sulfite? Al2SO3 3 is correct. Yeah, perfect. Okay, and let me explain it here. And the way you would write this, you need parentheses on this one because you're saying that you need 3 of these. So each of them have a -2, but you need 3 of them equals a -6. And that's going to balance out the aluminum, that each of them have a +3 times 2 equals +6. Okay, good, good. Yeah, so that's one of the toughest examples, really. Yeah, so Al2SO3 3. Okay. So sodium hypochlorite is next. Yeah, so on the exam, you would definitely have the list. Yep, so I'll be nice. The first time I taught this class, I had everybody memorize it, and then it occurred to me, well, why am I having you memorize it anyway? So it's yeah, it's something that you'll be provided. Okay, so sodium hypochlorite. Did anybody get that one? Yeah, NaClO. Yeah, exactly. So the ions involved are those, so you just put them together. NaClO. Okay, and then magnesium bicarbonate. Sometimes this, you may see it as, without scribbling too much here, but bicarbonate, it could be hydrogen carbonate. Okay, so that means the same thing. Yeah, hydrogen carbonate or bicarbonate. It's just HCO3. So what about this formula? Mg, and then you need 2 of those. Yep, exactly. So it's magnesium, and then it's HCO3 minus, And so you need 2 of them. How about right here? HCO3, 2. Just like that. Yeah. Okay, and then the last one, sodium carbonate. And this, getting back to, the context, we're talking, about the carbon cycle and all the different ways that carbon is stored. This would be in the Earth's crust. And sodium, and especially calcium carbonate, are 2 big ones where, carbonate is this. Okay, so it is a place where carbon is stored in a compound. Okay, so sodium carbonate. Na2CO3, yep, exactly. Yeah, so the ions at that. CO3, 2 minus, and so you need 2 of these, 2 sodiums. So it's Na2CO3, yeah. Perfect. Okay, so any questions about going from name to formula then? Again, the strategy, just write out the ions and then see, how many you need to put together so that everything equals a 0 charge overall. Yeah, and the last one, you don't need to use parentheses because it's just 1 carbonate, right? So the only time you would need parentheses is if it were a 2 or a 3 or something like that. Okay. So let me get rid of those. Yeah. So that is the proper way. I wouldn't mark you wrong. If I have you do like some free answer, I'll have to think about this next exam. I may have you, it'll likely be all multiple choice, but I might have like short answer, and then maybe you take a picture with your phone and send it. I don't know. I don't want to make life hell for you guys, really. But I would not mark you wrong if you had parentheses on it. It's just not standard. Okay. All right, so let's go the other way. This, I think, is harder. Okay. So give the names of these compounds, okay? And so let's do the first one together again, and then I'll let you loose. I'll pause the video. This time I'll hope to remember to re-record after we get done. But in this case, you have to figure out what the charges are, and for, why it's harder is because for transition metal compounds, the name had the charge. Like this question 6, for instance, you were told it's chromium 2. Here in the formula, you're just given the formula, so you have to figure it out. And so does anybody have an idea what the charge of the iron would be for that first question? All right, Lexi got it. Yeah, +3 or 3 plus, exactly. And so how you get that is you look at what you don't know. And so, sulfate, or I guess not what you don't know, what you can figure out, I guess. And so sulfate, you know that has a -2 charge. And you know that you have 3 of them. So that means a -6. Okay, so this whole other side has to equal +6. Okay, but you have 2 irons, right? So it's like saying this, right? So 2 irons. So sort of like that, right? Where you've got +6 for the total charge. Not the plus on the bottom. Okay, but you've got 2 irons. Okay, so then that means that each have to be +3. Okay, and so with that, then what would the name be? Now that you have the charge in the iron, what is the name of that compound? Yep, iron 3, because that's the charge that we figured out. It is iron 3. sulfate. Yeah, good. Yeah, and just for semantics too, there is no space between the iron and the Roman numeral. Okay, so the only space is between the Roman numeral and the sulfate. Okay, and yeah, just make sure you know why it's iron 3. And I guarantee you, if this is multiple choice, iron 2 sulfate will be one of the answers. And it's very, very tempting because you see a 2 here, right? But remember, again, this charge, the Roman numeral is the charge, not how many. Okay, so it's iron 3 sulfate. Okay, so again, yeah, take a stab at all the rest. Okay, so 2 through 10 of these ones. And then, yeah, as you're working through, let me know if you have questions. Shout it out or text it, and we will reconvene. Okay, so showing answers to the above ones here. Let me scroll down so you can see. So number 2 is sodium phosphate, lead 2 nitrate. Okay. So what about number 9? Ammonium phosphide. Yeah, perfect. Yeah. Ammonium, and then if it's just the element by itself, it's just whatever it is with an IDE. So phosphide, or with AS, it would be arsenide or telluride, whatever. Yeah, good. And then the last one, last naming of today, number 10. Yeah, exactly. So yeah, tin and lead, you need Roman numerals, and so that is tin 2 bicarbonate. Or you might see it online or in books as this. Okay, so both are correct. Okay, so you can either say bicarbonate or hydrogen carbonate. Okay, so any questions about naming that is still not clear? Everybody's good so far? Hopefully. Okay, good. All right. Okay, so let's now, with that under our belts, let's go back to the second big topic we introduced at the last lecture, and that was dealing with moles and grams and all that stuff. So this is kind of where we stopped last day. Decrease it a little bit, okay. So we were talking about counting, and so the way that chemists count is using Avogadro's number. And so remember that we talked about 1 mole of anything, and the shorthand term of this is MOL, okay, is equal to an Avogadro's number. Okay, so if we have 1 mole of pencils, then it's an Avogadro's number of pencils. Okay, and it's this huge number. It's a number that you're going to use a lot to do calculations. Like after your next reading assignment, I'm going to post some other questions on Connect for you to do. And so you're going to use this number a lot. So you'll probably have it memorized, but I will also, give this number on exams just in case you blank. Okay. But it's really a huge number that indicates, even though their masses may be quite different, like 6 golf balls weigh different than 6 tennis balls, right? It's a way to count other than using grams, okay? And we're going to look at kind of the application of this, why it makes more sense to talk moles of a reactant, doing its thing to produce moles of products, why we use moles instead of grams for that, okay? So this is kind of the little schematic that I drew last day. So at the last lecture, I talked where you've got moles at the middle, and then to get out of it, I guess mine was a little more explicit. Where you've got something like this, and then grams, and then to get out of moles, you're multiplying by something. Okay, by molar mass or molecular weight. And then to get back, you're dividing by that same parameter. Okay, and then to get to number, that's where you're using Avogadro's. Okay, or to get back, you're dividing by that, Avogadro's. Okay, and so, for instance, if you have 1 mole of oxygen atoms, you have a mass of 15.9994, and that comes right from the periodic table. So if you look at, oxygen in the periodic table, you'll have, it's usually written underneath, and then it's element, what is it, 8 or something like that, maybe. Is that right? 6? I think so, yeah. Okay, so this is what you would see in the periodic table. So that is your atomic mass. Remember, it's the weighted average of all the different isotopes. And so that's what you would use for 1 mole of oxygen atoms. It weighs this many grams. Okay, so the units that are in the periodic table, those, from now on, instead of it being U that we talked about, this, mass unit, we're going to use it in terms of grams per 1 mole. Okay, so that's going to be the unit. Whoops, you're not seeing that. That's going to be the unit from now on. How many grams for 1 mole? Okay, so that's if you have oxygen atoms. What is the molar mass of let's say 1 mole of oxygen molecules? So what do you think? So oxygen atoms had, let's say, 15 grams. That's how much they weighed. What about oxygen molecules? So what is an oxygen molecule? So which one of these do you think? Yeah, so oxygen molecules, it's O2. Yep, good. Okay, so this is when we're talking individual atoms. These are molecules, okay? Or in a reaction, it really may not be explicit, to be honest. So this one, for instance, okay, then we have to balance. So what is that, 2 and 2? Okay, so this one, it would just literally say hydrogen reacts with oxygen to produce water. Okay, so it's not saying hydrogen molecules or whatever. So remember those 7 elements that have to be diatomic. Okay. All right. So what is the molar mass then of O2? How would you get that? So if each oxygen is 15.9994 and you have 2 of them, it's just 2 times that number, right? So just be 2 times 15.9994 grams per mole is something like close to 30. I'll get the exact here. 15.9994 times 2 is 31.9988 grams per mole. Okay, so that's the molar mass for oxygen. Okay, and so the way you get molar masses then is you just add up all the atomic masses. And so the molar mass for NaCl, you would just look in the periodic table for sodium, okay, and that's 22.99. And then you look up chlorine is that, and you just add them together, okay? So, because you've got one of each. This one, LiNO3, what is the name for this? So instead of me just saying LiNO3, what should I call it? Now that you're all the experts in naming here. Yep, lithium nitrate. Good, good. Okay. Okay, so 1 mole of lithium nitrate, the way you get that is, again, you get the numbers from the periodic table. So each lithium is that, and you've got one of them. Then you've got 1 nitrogen, and you've got 3 oxygens. Okay, so you just add up everything. Okay, so let's do a really complicated one. So how about, well, what's one that we did in our naming here? How about, yeah, what about magnesium bicarbonate? Okay, and just to speed it up a little bit, what we had for bicarbonate was this. Okay, and I guess you need the molar masses, don't you? Okay, so let me pull up a periodic table here. Or if you have one in front of you, feel free to use that. There we go. This actually is the version that I will put, this is the browser actually that I will have on exams for you. So you'll be able to open this as a window on your lockdown exams. Okay, so there we go. So magnesium bicarbonate. Okay. Carbon and oxygen is there. So for this, hopefully you can see these numbers if they're big enough. There you go. Okay, you're just going to add them up. And so magnesium has an atomic mass of 24.305. Hydrogen, whoop, I guess hydrogen was off. That's 1.008. Carbon, 12.011. And oxygen is 15.999, I guess, for this periodic table. Okay. And so you're just adding them up. We've got 1 magnesium. Okay, how many hydrogens do we have? Yep, exactly. Yeah, because this 2 implies that it goes really anything inside the parentheses, right? So we have 2 hydrogens, and then that means 2 carbons. And how many oxygens? Yep, good, good. That's 6. Okay, so you just do all of that. I don't know if did anybody work that out yet, the whole thing? But 24.305. 0.008 times 2. 12.011 times 2. And 15.999 times 6. So did you get 146? Oh, over here. 146.337. If I did that right. Okay. So does anybody not get how to calculate molar mass? Okay. All right, so where we use that in this little chart is going between grams and moles. Okay, so we're using molar mass. And so, looking at, dimensional analysis, if we have grams, what do you think we have to do? Well, I guess, if you're looking at that chart, you can figure it out. But if we want to get moles, right, this is the way that grams cancel. And so that would be dividing. In other words, you go grams divided by molar mass will give you moles. Okay. There we go. Okay. And then likewise, if we want to go from moles we would then multiply by the molar mass to give you grams. Okay. I don't know why I can't move that over. There we go. Okay. So here's the last question I'm going to ask today then, is if I have, let's say 10.13 grams of water, how many moles do I have of water? Okay, and again, you can assume hydrogen 1.01 and oxygen is that. Okay, so I wish I could give a piece of chocolate to whoever could get the answer first, but I guess virtually not possible. I'll give a little shout out here. So how many moles from 10.13 grams? Okay, so the way to calculate it is, again, if you're looking at this little flow chart, right, you're starting here, and you want to go here from A to B, okay, and so you're dividing by the molar mass of water. Okay, so that would be 10.13 grams divided by its molar mass. Okay, so water is, about 18. Let me do it exactly here. So 15.999 plus 1.01 times 2. So that's 18.019 grams per mole. Okay, so the grams cancel and you end up with so many moles. So 10.13 divided by that is 0.5622, I guess, as far as sig figs go. Okay, so questions about that? Anybody does not understand how I went from grams to moles there? Okay, and so now once we have moles, I can determine how many individual molecules of water I have. Okay, so we are here in this little flow chart, right? We're in the middle. If I want to know the number, then I'm just going to multiply by Avogadro's number. Okay, so once you have moles, then if you do 6.02 times 10 to the 23rd, that gives you how many molecules of water. And it'll be an insanely large amount. Okay, so that times 6.02 e to the 23rd is 3.38 times 10 to the 23rd molecules. Okay. And so on an exam, if it's multiple choice, I say this every semester, and then I notice on the exam there's always mistakes made. So hopefully, you get this. On the multiple choice exam, there will be answers like, 4, 0.138, and then times 10, what was it, to the 23rd? And then we'll say 3.38 times 10 to the minus 23rd. Okay, so one time I put this exact, or very, very similar question on the exam, and I was really surprised how many people went for that one. Okay, that if you have 10 grams of water, right, that's something you can hold in your hand, right, and see with the naked eye. There's probably more than 4 molecules there, okay? Because molecules are so small you can't see them, right? Or you can't have part of a molecule, right? That doesn't make any sense. As well as this. This is a really small number, okay? And so what I'm trying to say is that oftentimes, it won't be this clear cut that only one of them will be the right magnitude, but at least maybe 2 of the answers in the multiple choice will be huge, huge numbers. And so that can help you limit, no, that doesn't make sense, no, and then, that's the only one, or maybe 2 possibilities, that are kind of in the realm of possibilities. Okay, so you should be looking, if I'm asking how many atoms, how many molecules are in, a few grams of something, look for an insanely big number, okay, 10 to the 22, 23, 24, something like that. Okay, all right, so that is all I wanted to cover today. So hopefully everybody is with me, I guess, on these topics. I guess before I sign off, any questions, naming or what we've done so far, just really going, grams to moles and numbers so far. Is everybody cool? Okay, I'm not seeing any questions or any WTF texts here. Okay, so I assume everybody is good. All right, you're not too freaked out here. Yeah, let me know, I guess, by email if you prefer that, so you don't have your business in front of everybody. But yeah, let me know by email if you have questions, if you feel more comfortable. But that is it. Okay, so. I will touch base again, I guess, Wednesday. We'll talk more about these and talk about actual reactions. But that is today's lecture.